Hello and welcome to more difficult questions on S1. Let's continue with the video. This is from June 22, 5-3, variant 5-3. So this is practicing for a long jump competition. He counts any jump that is longer than 6 meters a success. On any day, the probability that he has success with his first jump is zero point 0.2. For any subsequent jump, the probability of success is zero point 0.3. If the previous jump was success, then zero point 0.1 otherwise. So this makes 3 jumps. Okay. So a tree diagram. So success, failure, that's the first jump. Point 2 and point 0.8. For any subsequent jump, the probability of success is zero point 0.3 if the previous jump was a success and zero point 0.1 otherwise. And point 0.7, let's first draw this and then, so that's when all jumps have been successful right on the go. Let's say second, third, third, success, failure, and if the previous one is a failure, then 0.1 and 0.9. Success, failure, zero point 0.1 and 0.9. Success, failure, 0.9, 0.1. If the previous one was a success, then this has to be 0.3 and 0.7. Okay, that's the tree diagram for this. Let's quickly check if we've drawn the right tree diagram. I don't want to make any mistakes here, so I'm just going to open up the marking scheme quickly and see. 0.3, 0.7, 0.1, 0.9, 0.3, 0.7, 0.1, 0.9. Yep, okay. Now, the recommended thing to do is to also write down if what your outcomes have been. Okay, so let's quickly write that down. So that's 3 successes, success, success, failure, success, failure, success. I'm going to probably end up using this in the next part. Okay. Then in the next part it says find the probability that Sajid has exactly one success given that he has at least one success. So at least one given exactly one. Oh, sorry. Exactly one given at least one. Okay. So probability of at least one in the denominator and probability of one and at least one. So just probability of one then in the numerator. Okay. Exactly one. Because exactly one automatically means at least one. Okay, so at least one. Which outcome should I take? At least one success. Okay, so at least one success is this, and this. So that's a lot. So I can just do this for the denominator instead of adding all of them up. I can just do 1 minus failure, 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 which is zero point 0.8 into 0.9 into 0.9. Then at least one success has exactly one success. So what are the ones in the numerator? Exactly one success. So that's this one, that's this one, and that's this one. So 0.2, 0.7, 0.9, 0.2, 0.7, 0.9 plus 0.8, 0.1, 0.7 plus 0.8, 0.9, and 0.1. So you see Drawing the tree diagram appropriately helps you calculate the other parts as well. Um, point 0.2, 0.7, 0.9 plus 0.8, 0.1, 0.7 plus 0.8, 0.9, 0.1 divided by 722. Okay, on another day, Sajid makes 6 jumps. So I've told you that there's 6 jumps. Find the probability that only his first 3 jumps are successes or only his last 3 jumps are successes. So success, 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 and failure, failure, failure. Or I can have failure, 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 and success, success, success. So what's the first success? That's point 2, then point 3, then point 3. Then if the previous one was a success, then the failure needs to be point, if the previous one was a success, was point 1 otherwise. Okay. So point 7, point 9, and point 9 plus this one, point 8, point 9, point 9, point 1, then point 3, and then point 3. Okay, you have to be careful about the ones that are about the transition success to failure. Okay, let's see if we get the correct answer. I'm getting 0.101026 for the first one. And a very small number for the second one. I'm getting 0.016038. It would be 0.0160. Let's check if that is the right answer. Yep, that is the right answer. So, long question. Okay, let's see what our next difficult question is. This is from November 2252 and it's in permutations and combinations. Let's look at this. It says find the number of different arrangements of the 9 letters in the word alligator. Let me first just write my identical letters in which the two A's are together and the two L's are together. So two A's, two L's, 5 more, box gets a dash. So 7 factorial, go inside the box and then divide by the identical letters in the end. So 7 factorial basically, 5040. Okay, I'm just going to open up the marking scheme again to verify that I'm doing these correctly. Okay, so part 2 says the 9 letters in the word alligator are arranged in a random order. Find the probabilities. Probability is about calculating the denominator first, so do that first. So the denominator is unrestricted combinations, so 9 factorial, 2 factorial, and 2 factorial. Okay, so if I want 6 letters, so I'll have 1, 2, 3, 4, 5, and 6, and then in A, so that's 6 and 2, 8 letters, and then A here. Okay, so remember that there could be another situation where I have an empty dash at the start and not at the end. Okay, that would be another situation. Now for the else, remember that they have to be in a box. Now the box can't come up at the end, so I can't just simply say that the box is a dash and then I can shuffle around the dashes. What I need to think about here in this case is that if there are two L's here, they could appear either here, one position, two, three, 4, and 5. So there are 5 different positions for the L's. So I'm going to say that there are 5 positions for the L's, and the remaining letters are 1, 2, 3, 4, 5. They're all different letters, so 5 factorial there. Okay, so what's 5 into 5 factorial? Let's try to do that. 5 into 5 factorial. That gives me 600. So that would be a similar case here as well, 5 into 5 factorial, and that would also give me 600. So I get a total of 1200, and what my denominator is 9 factorial over 2 factorial. I don't know, I didn't calculate that. So let's quickly calculate that. That's 90720. And that is the correct answer. Okay, moving on to part C for this one. Find the number of different selections. This was a 5-mark question, so it's tough. Okay, so think about it before you attempt it. Find the number of different selections of 5 letters from the 9 letters of the word alligator, which contain at least one A and at most one L. So it could be A and no L, or two A's and no L, or it could be A and one L, and two A's and two L's. Two A's and one L. Sorry, no two L's allowed. So if there are number of 5 letters, so A's and L's, so I have 5 letters remaining, so A and no L, so 5C4, 5C3, 5C3, and 5C2. 5C4 is 5, 5C3 is 10, 5C3 is 10, 5C2 is also 10. So that's giving me 35. I don't know if that's the correct answer. I will have to check. Yes, that is indeed the correct answer. Okay, moving on to the next difficult question. This is the writ activated from 5/3 November 22. Okay, so this says find the number of different arrangements of the 9 letters of the word activated. So let's write activated in our form first. So I have 9 factorial over 2 factorial into 2 factorial. I think that came out as 90720 earlier as well. So I'm just going to write that. 5/3. Yeah. Find the number of different arrangements of the 9 letters in which there are at least 5 letters between the two A's. Okay, so A, 5 and 2 and 7. Okay, so A could be here and here, or A could be here and here. Okay, so there are 3 different positions. What about the other letters? So that's 7 factorial over 2 factorial. That's also 7 factorial over 2 factorial. And that's also 7 factorial over 2 factorial. You could say 3 into 7 factorial over 2 factorial, because there are 3 different ways of arranging the A's. So that sort of gives me an answer. Yeah, it gives me the correct answer. Um, oh, it says at least 5 letters. So I could have more cases. 6 letters. Okay, so there are 2 cases for that. That's again 7 factorial over 2 factorial. Or I could have this last case. There are lots of cases. 1, 2, 3, 4, 5, 6, 6. Okay, yeah. 7 factorial over 2 factorial into 6. That gives me 15120. So at least 5. I missed that earlier. Okay. Then there's 5 letters are selected, 9 from the word activated. Find the probability that the selection does not contain more T's than A's. Now remember, this is the selection question and it's about probability. The first thing that I go on and decide is the denominator. The denominator always has to be the unrestricted combination, so 9C5. But remember that whenever you are doing this in combinations, as I explained in this in the other video as well, that you end up double counting in the denominator. Now 9C5 is not actually the total number of combinations. Why? Because it's a lot of double counting. I've double counted the A's, I've double counted the T's. So I'm going to do the same thing in the numerator as well. Selection does not contain more T's than A's. So it should have more A's than T's. Okay, so more A's than T's is my motto. So I'm going to say that this is 1A, no T, 1A, and no T's on more A's than T's. Okay, so 2A, no T, 2A, and 1T. Okay, what's the method of CT? Oh, let me just write first. Activated. I get confused when I don't have the letters written in front of me. Okay, 1, 2, 3, 4, and 5 are the letters. Okay, so 2C1, I told you that I'm now going to double count. So 2C1 into 5C4, 2C2 into 5C3, 2C2, 2C1, and then 5C3. Okay, not contain more T's than A's. It could contain an equal number of T's and A's as well, right? So I'm going to say 1A and 1T and 2A and 2T. Okay, ideally I should have done 1 minus contains more T's than A's. I think that's the better way of explaining this as well. But now that I've done it, I'm just going to stick to this method and see if I get the correct answer. Okay, and then I could have no A's and no T's as well. Okay, let's see if we end up getting the correct answer. I'm not absolutely sure that I've done this correctly. Okay, what's 9C5? Because I may have missed one of the conditions. I'm getting 126 in the denominator and 86 in the numerator. 43 over 63. That sounds like a very odd answer. I'm not sure if that is correct. Yep, that is the correct answer. In fact, although this could have been done in a shorter way, if I had done 1 minus contains more T's than A's, that would have been easy. I could have said 1T and no A, 2 T's and no A, and 2 T's and 1 A, and just subtracted that. Okay, so we could have done that too. Okay, moving on to the next difficult question that I have here for you. I have still a lot more to go on, so there'll probably be a third video as well. Okay, Sam and Tom are playing a game which involves containing 5 discs and 3 red discs. They take turns to remove one disc from the bag. At random, discs are removed and are not replaced into the bag. The game ends as soon as one player has removed 2 red discs from one bag. That player wins the game. Okay, Sam removes the first disc. Find the probability that Tom removes the red disc on his first turn. So I'm just talking about the first turn right now. So I'm going to start drawing my tree diagram and say that this is sorry. Okay, so about the first turn, find the probability that Tom removes a disc. So Sam plays first, I think. Okay, so this is Sam's turn. He can put a white or a red. So now there's a bag containing 5 out of 8 and 3 out of 8. They take turns to remove one disc from the bag. Discs that are removed are not replaced. Okay, so the game ends as soon as one player has removed the player wins the game. Okay. Then this is Tom's turn. So white and red, Tom, Sam. So that's 4 out of 7 and 3 out of 7. Tom, 2 out of 7 and 5 out of 7. So Tom selecting a red disk is basically 5 over 8 into 3 over 7 plus 3 over 8 into 2 over 7. Okay, I'm going to move this down and say that that's my final answer. I don't know what year this is. This is still the same year, I think. So November 22, question number 7. Yeah. Okay, 3 over 8 into 2 over 7 plus 5 over 8 into 3 over 7. Yeah. So that gives me 3 over 8, which is 0.375. Okay, I'm going to use this tree diagram later on. So I'm just going to pull this down. There's a lot of space. Find the probability that Tom wins the game on his second turn. Okay. So after this, what is going to happen is that Sam is again going to take a turn. Now, for the white disc, yes, the turn is going to keep going on like that. Sam, okay, white, red. Who needs to win? Tom wins, okay? So that's 3 out of 7, 3 out of 6, and 3 out of 6. Um, Tom wins on his second turn. Tom wins on his second turn. That simply means that I don't need to sort of draw all the branches here. What I can sort of manage with is just figuring out where Tom has already gotten 1 in his first turn. So that should be this branch. So I technically don't really need this branch. Even if I were to ignore this, that would be fine. Okay, so I'm going to go on and do the branches that really matter. Okay, Sam gets a white or a red. So that's 2 over 6, and that's 4 over 6. And then whatever Sam gets, if Tom gets, this is Tom again, white and red. So if Tom wins here, that's 3 out of 5, and that's 2 out of 5. So Tom wins on his second turn. Here also Tom wins on his second turn. This is Tom, white, red, 1 out of 5. Wins. Tom wins. Okay. Again, Tom will win from here if he's already had 1 red disc to go with him. Sam. Okay, and then I have Tom. So Tom could win here, or Tom could win here. White or red? White or red. 4 out of 5 and 1 out of 5. Okay. Okay. Now this branch couldn't have happened. Why? Because Sam has already won. So that's the only branch that could happen, and Tom wins here. So that's a tough question to solve. Let's quickly now write down the probabilities. 5 over 8, 3 over 7, 4 over 6, 2 over 5. 5 over 8, 3 over 7, 2 over 6, and 4 over 6 and 2 over 5. 4 over 6 and 2 over 5. That's the first Tom wins. The second Tom wins 5 over 8, 3 over 7, 2 over 6, and 1 over 5. 5 over 8, 7, 2 over 6, and 1 over 5. And then 3 over 8, 2 over 7, 5 over 6, 3 over 8, 2 over 7, 5 over 6, and 1 over 5. So tough question. 5 into 3 into 4 into 2 gives me 120. 8 into 7 into 6 into 5, 1680. So 1680 or 30 and 30. So 30 plus 30 plus 120 divided by 1680. 3 over 28, if that is the correct answer. Yep, that is the correct answer. Let's see this last part that we have here. Find the probability that Sam removes the red disk on his first turn, given that Tom wins the game on his second turn. So given Tom second, win. So that's the probability of what I just found, 3 over 28. And I want Sam or 1 on his first. So where is Sam removing the red disk on his first turn? That is this branch. So the last branch that I calculated. So that's 30 over 1680. I'm just going to write that as it is and see if we get the correct answer. 1 over 6. Okay, that is it. Okay, continuing with the questions. This one says 80% of residents of Kinwawa are in favor of a leisure center being built in the town. 20 residents of Kinwawa are chosen at random and asked in turn whether they are in favor. So 20. Find the probability is more than 17. So more than 17. So 18, 19, and 20. So I think that sounds easy. 20C18, 0.2 power 2, 0.8 power 18 plus 20C19, 0.2 power 1, 0.8 power 19 plus 20C20. N is 20 and 0.8. Point 2061. Okay, then find the probability that the fifth person asked is the person who is not in favor of the leisure center. Okay, so what I want is that fifth person as the first person. Okay, so this is like a geometric distribution, but I'd rather explain it to you. But the first person was in favor, the second person was in favor, the third person was in favor, the fourth also was in favor, the fifth was not in favor. Okay, so that's 0.8 power 4 into zero point 0.2. The idea in this question is that your success has sort of changed. It's no longer people who favor the center, it's people who do not favor the center. Okay, let's check if we are doing this correctly. Question number 3. 0.206 and 0.08192. Yeah. Find the probability that the seventh person asked is the second person who is not in favor. So there is one person in the first 6, and then the seventh person is not in favor. Okay, and in the first 6, first to sixth, there is one person. Okay, now you can do it in two ways. You can say that favor, 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 not favor, and not favor. This is the sixth and this is the seventh. Here I've assumed that in the first 6, the sixth person is not in favor, but they could be in any order. So I'm going to say that 0 0.8, 0 0.8, 0 0.8, 0 0.8, 0 0.8, that's 5 times, 0.2, and then 6 factorial divided by 5 factorial. I'm arranging them. Or I could also treat that as a binomial and say that I want one person to be not in favor, so the rest of the five should be in favor, and then I want one failure at the end as well. So that's the seventh person basically not in favor. Okay, so I'm going to put a point two here as well. Okay, so five people in favor, then one not in favor, and they've been shuffled around. And otherwise, you could also do it with the binomial that I've done here. That gives me 0.0786. Let's check. Yes, that is indeed the correct answer. Okay, moving on to the next question then. We have February, March 23, question number 5. Marco has four boxes labeled K, L, M, and N. He places them in a straight line in the order K, L, M, and N with K on the left. Marco also has four colored marbles. One is red, one is green, one is white, and one is yellow. He places a single marble in each box at random. Events A and B are identified as follows. The white marble is in either box L or box M. Okay, the red marble is to the left of both the green marble and the yellow marble. Okay, the red marble. Determine whether or not A and B are independent events. Now, since this is a question on independent events, what I think is I should know where the intersection also happens. So let's think about it first and then try to do it. This is just a 3-mark question. So it's not a long solution, but it is supposed to be thought. The white marble is either in box L or box M. Okay, so white marble could either be here, and all of the others could be not white, and it could be here, and the others could be not white. Okay, so I could have 3/4, 1/4, uh, one side, sorry, two twos and one ones. Okay, and then I could have, so that gives me 1/4. And I could have the same for this one as well. I could have 3/4, then 2/4, then 2/3, 1/2, and 1/1. So plus gives me half. So that's event A. The probability of A is half. Okay. With the other situation, the red marble is to the left of both the green marble and the yellow marble. That is what I have to think about. Now, I could do this easily with permutations and say that the denominator has to be 4 factorial, which means that the denominator is 24. Now, how many such outcomes can I think where marble A is to the left of both the green marble and the yellow marble? Now, if the red marble was here and green and yellow could be anywhere here, so I could say that they could be arranged in any way. So that's 3 factorial arrangements. Okay, any of the 3 could appear here. Now, if red was here, um, the white has to be here, and then only the green marbles could green and yellow marbles could be arranged. So that's 2 factorial arrangements. So what's 3 factorial? It's 6. What's 2 factorial? It's 2. So I get a total of 8 out of 24. So that is my probability then. Okay, how many such events can I think of where there is an intersection? Now in this case the white is appearing here. Okay, so is that an intersection? No, that is not an intersection. I wanted white to appear in either box L or M. So it's in this case that the intersections will lie. So when it appears in here, I'm going to say that there are, now for the intersection also the denominator has to be 24. That's the total possible outcomes. How many such outcomes are there where white is in either L or M? And it also fits the other criteria that red is to the left. Why? Because an intersection means both. So if white was here, that would be 2 factorial arrangements. If white was here, that would again be 2 factorial arrangements. So that means that there are a total of 2 factorial plus 2 factorial arrangements for A intersection B. That's 4 out of 24. Now to determine whether, let me check if I'm doing it correctly. Yes. A intersection B is probability of A into probability of B. If they are independent events, let's check. 4 out of 24, 1 out of 2, and 8 out of 24. Okay, so that gives me 1 out of 6 and 1 out of 6. So events are independent. Okay, slightly more challenging question than you've seen before. It's a small 3-mark question, which means that the solution is not very long, but it is more complicated than the previous ones. Moving on to the next, this is from June 23, 5-1. Find the number of different arrangements of the 8 letters in the word cocooned. Okay, so 8 factorial divided by 3 factorial into 2 factorial. 3360. Find the number of different arrangements of the 8 letters in the word cocooned in which the first letter is O and the last letter is N. First letter is O and the last letter is N. So I have 6 factorial in the middle. How many O's got arranged? 2 O's got arranged and 2 C's got arranged. 180. Then we have find the probability that a randomly chosen arrangement of the 8 letters in the word cocoon has all three O's together, given that 2 C's are next to each other. Okay, let me just open up the marking scheme to verify that if you've done the other parts correctly. Three. Okay, 180 and 3360. Yeah. Okay, find the probability. Now I'm talking about probability that a randomly chosen 8 letter in the word cocoon has all three O's together, given that the two C's are next to each other. So there's a given condition as well. What is the given condition? The given condition is given C's next to each other and O's together. Okay, so my denominator is going to be C's next to each other. Just C's next to each other. How do I calculate that? I will keep C's in a box and arrange the rest of them. So I'm going to say 6 factorial going in, sorry, the box is also a dash, so 7 factorial. I'm going to go inside the box and then divide by the identicals. So that's my denominator. That gives me 840, I think. So my denominator is 840. In the numerator, I have the C's next to each other and the O's also next to each other. 5, 6, 7, 8, 9. Okay. So 5 factorial into 3 factorial into 2 factorial divided by 2 factorial and 3 factorial. 120. Okay. The intersection. Common part. Okay. Let's see if we get the correct answer. Yes, that is indeed the correct answer. The answer is 1/7 and that is correct. Okay. Moving on. Now to the next question that I have. A sports event is taking place for 4 days beginning on Sunday. The probability that it will rain on Sunday is 0.4. On any subsequent day, the probability that it will rain is 0.7 if it rained on the previous day and 0.2 if it did not rain on the previous day. Find the probability that it does not rain on any of the 4 days of the event. Okay, so what I can do is I can make a tree diagram out of this. But an easier way of handling this would be to say that I have Sunday, Monday, Tuesday, and Wednesday. I want not rain, I want not rain, and not rain, and not rain. So I'm going to say that this has to be zero point 0.6. And if it has not rained on the previous day, and 0.2 if it did not rain on the previous day. So zero point 0.8, zero point 0.8, and zero point 0.8. So that's zero point 0.6 into zero point 0.8 cubed, 0.3072. Find the probability that the first day on which it rains during the event is Tuesday. Okay, so first day, I want this to be rain, not rain, not rain, and I don't want Wednesday. Okay, so not rain on Sunday is zero point 0.6, on Monday it's zero point 0.8, and then if it's not rain on the previous day, it's zero point 0.2 on the next. Zero point 0.096. We should also verify our answers simultaneously. I don't know what the year this is. This is February, March, June 23, 52. 2. 12 over 25, 0.096, and 0.3072. Okay. Part C. Okay, part C says find the probability that it rains on exactly one of the days of the event. So Sunday, Monday, Tuesday, Wednesday. Let's say it rains on Sunday, then not rain, then not rain, then not rain. If it does not rain here, it rains here, then rain, not rain, not rain. Then not rain. I'm choosing each of these as one day that it could rain, so not rain, not rain, not rain. What's the probability of raining on Sunday? It's 0.4, I think. Okay. And if it's rained on the previous day, the probability of raining again is 0.7, so that's 0.3. If it's not rained on the previous day, then the probability that it's going to rain is zero point 0.2. So this has to be 0.8 and zero point 0.8. Then 0.6, zero point 0.2, zero point 0.8. No, wait. It has rained. So raining again has zero point 0.7, so 0.3, and then 0.8. Okay, then it's zero point 0.6 and zero point 0.6 for this, zero point 0.8 and zero point 0.8 for this, and it's not rained, then raining again is zero point 0.2, so this has to be zero point 0.2, and if it's rained, the probability of not raining is 0.3. No, zero point 0.8 here. Okay, let's check if I have all the conditions: zero point 0.4, 0.3, 0.8, 0.8. That gives me 48 over 625. 0.6, 0.2, 0.3, and zero point 0.8. That gives me 18 over 625. Then 0.6, 0.8, 0.2, and zero point 0.3. 18 over 625 again. 0.6, 0.8, 0.2, 0.2. 48 over 625. So a total of 0.2112. Okay, moving on to the next question now. I still have a lot of them left. Okay, Jasmine throws a face excited die at the same time and notes the numbers on the uppermost faces. The events A and B are defined as follows. The sum of the two numbers is less than 6. The difference between the two numbers at most is 2. So 1, 2, okay, let's first mark is less than 6. So A. Then I could have, yeah, that's A. Whereas B, the difference between the two numbers is at most 2. So difference is 0, difference is 1, difference is 2. Difference is 1, difference is 0, difference is 1, difference is 2. Difference is 2, difference is 1, difference is 0, difference is 1, difference is 2. 4, 2 is 5 and 3, 5 and 4, 5 and 5, 5 and 6. 6 and 4, 6 and 3. Okay. Determine whether A or not A and B are independent events. The probability of A is 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 over 36. Probability of B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. That's A intersection B. 2, 3, 4, 5, 6, 7, 8. So is 8 over 36 equals to 10 over 36 multiplied by 24 over 36? We'll know in a bit. Gives me 2 over 9. That gives me 5 over 27. So not equal, not independent. What year is this? This is June 2353. I'll have to open up the marking scheme. Yep, not independent. Find probability of B intersection A naught. So this means I want to find the probability of B not intersection given A naught. So denominator is probability of A naught. A itself was what? A itself was 10 out of 36. So this should be 26 out of 36. Okay. What is the probability of B intersection A naught? Okay. So where are the A naughts? The A naughts are everywhere that A isn't there. So this is A naught, this is A naught, this is A naught. And they are they intersecting with B? Yes, they're intersecting with B. What are the intersections? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, I think. If I'm correct, they should be 16. Yeah. So that's 16 over 26, which is 8 over 13. Let's just write 16 over 26. Okay, that should be the final answer. Okay, moving on to another difficult question. Let me take you to November 2351. It says a red spinner. I'm just going to open up the marking scheme simultaneously. Okay, a red spinner labeled this. When the spinner is spun, the score is the number on the side given. When it lands, the random variable x denotes the score. The probability distribution table for x is given as follows. Show that probability p equals to 0.12. Okay, so that's simple, I think. Okay, a fair blue spinner and a fair green spinner each have labeled 1, 2, 3, 4. All three spinners, red, blue, and green, are spun at the same time, find the probability that the sum of the three scores is 4 or less. So I'll have to imagine the scores because I cannot make any diagram for a three-sided spinner. For three spinners, basically a four-sided spinner, but three spinners. So I can't really make a possibility diagram. Let me start thinking of the outcomes. Let's start with 111. The sum is 3. 112, the sum is 4. Okay, that should be it. And 121, the sum is again 4. And 211, the sum is again 4. Okay, so what's the probability of getting 1 on the red die? It's 0.28. So all of these are 0.28 first, 0.28, 0.28. Or the probability of getting a 2, it's P, so 0.12 here. The other two are fair. So I'm going to say that 1/4 and 1/4. All of these are 1/4. Any score on the blue or the green spinner is 1/4. Okay, so I'm going to say that it's 0.28 into 0.25 squared times 3 plus 0.12 into 0.25 squared. 3/15 total. Okay, this part says find the probability that the product of the three scores is 4 or less given that x is odd. Now I'm talking about product, so I'm just going to write product, and it's a conditional probability. So given x is odd. X is odd means that x is the number on the red die. So it could either be 1 or 3. So 0.28 plus 2p, and p was 0.12. So my denominator has to be 0.52. Now starting with the outcomes, let's start with a simple 111. I know that the red die has to be an odd number and the product could be less than 4. So that's 1. The product, multiplication. Okay, so 112. The product is still odd. The product is still less than 4 and x is odd. 113, 114. Okay, let's just move that a little bit here. Okay. So 114, 115 can't be there. So I can have then 121. That's 2. 122. That's 4. 123. No. I could have 131. That's 3. 132. No, that's not possible. Then I could have 311. I'm skipping 2 on the red die. Why? Because I need to keep that as an odd number. Okay. So 1, 2, 3, 4, 5, 6, 7, 8. Let's see if we are doing this correctly. 1, 2, 3, 4, 5, 6, 7, 8. Okay, there's one more outcome that I've missed, and that should have been my first thought. Okay, 1, 4, 1. So getting 1 on the red die is simple. It's 0.28 from the table above. So all of these are 0.28. I'm just going to write that. What is the probability of getting a 3? It's 2 times p, so 0.24 in the end. Okay, and the rest all have to be a fair. So 0.25 into 0.25, so 0.25 squared. That's the idea of getting the numerator for this. So the denominator is 0.52. I have 0.28 into 0.25 square for 8 times and plus once I have 0.24 into 0.25 square. Let's see if we get the correct answer. 31 over 104. Okay. Okay, so this question is from November 2351. This is question number 6. It says in a restaurant, the tables are rectangular. Each table seats 4 people, 2 along each of the longer sides of the table. 8 friends have booked 2 tables, X and Y, Rajatsu and Dan, all 3 friends. Okay, the 8 friends will be divided into 2 groups. I'm just dividing into 2 groups right now. One group for table X and one group for table Y. Find the number of ways in which this can be done if Rajat and Sue must sit at the same table as the other. So this is table X. Let's say Rajat and Sue want to sit here. So on table Y, you will have Tam sitting. Okay. Now they don't want to arrange themselves, so it's just about people who want to sit with Rajat and Sue. So I'm going to say that there were a total of remaining 5 people, and 2 people will sit here. Okay. And then multiplied with whoever remains will sit with Tam. But it could be other way around as well. I could have table X and Tam could be sitting here. So 3 people would sit with Tam, and table Y, the remaining people will sit with Rajas and Sue who are sitting here. Okay, on any side, it doesn't matter. I'm not arranging them right now. It's just 5C2 into 2, I think. I should verify this answer. I don't know what year this was. November 23. Yeah, question number 6. Yeah, that is the correct answer. I am getting a total of 20 out of this. I will add the 2 conditions together. When the friends arrive at the restaurant, Rajas and Sue now decide to sit at table X. Okay, Rajas and Sue decide to sit here on the same side as each other. Okay, so either they could be sitting down here or up here, so that again creates 2 different conditions for me. Okay, so RS could be sitting here. Dan decides that he does not mind at which table he sits and the number of different seating arrangements. So table Y. So what is going to happen is that there will be people who decide who they want to sit with TAM, with R and S, and say that there are 5C2 people, and then those 2 people will shuffle between themselves. Rajas and Sue could also shuffle between themselves. Then whoever remains will sit on the other table. Okay, this shouldn't be 5C2, this should be 6C2 because Tan is also now sitting with that. Okay, and then I have 4C4 into 4 factorial. The other table is, sort of no restrictions. This 2 factorial is for the other people sitting here, and the other 2 factorial is for Rajas and Sue switching between themselves. Then if Rajas and Sue are sitting on that side, so that's 62, again 2 factorial into 2 factorial, and then 4C4 into 4 factorial, that's for Rajas and Sue switching sides, so that's basically just into 2. 1440 and 1440 plus 1440, 2880. Okay. As they leave the restaurant, the 8 friends stand in line for a photograph. Find the number of different arrangements of Rajas and Sue stand next to each other, but neither is at the end of the line. Okay. Okay. So Rajan and Sarusu could be standing here, here, here. So 1, 2, 3, 4, 5. There are 5 different positions that Rajat and Sue could be standing. So 5 into the remaining box, the remaining people, which is 6 factorial, into Rajat and Sue switching between themselves. So going inside the box and saying 5 into 6 factorial into 2 factorial. I hope that's the correct answer. Yeah, 7200. Okay, showing you the last few questions that I have here now. It says Freddy has 2 bags of marble. Bag X contains 7 red marbles and 3 red marbles. Bag Y contains 4 red marbles and 1 blue marble. Freddy chooses 1 bag of the bags at random. Okay, so when he's choosing a bag, the first sequence of events is choosing the bag. A marble is removed at random from the bag and not replaced. A new red marble is now added to the bag. Okay, let's first deal with 1 marble. Okay, so if a red was removed and a red was added, then I still have a total of 7 reds. What about the total in the denominator? I removed one and added one, so that's 10 again. Okay, that should leave 3 over 10 here. Now a red was removed and a blue was removed and a red was added. So the blue have fallen, but the total has remained the same. So that's 8 out of 10. So a red was removed and a red was added. So that's 4 out of 5. So that's 1 out of 5. A blue was removed and a red was added. So 0 out of 5 and 5 out of 5. You actually don't need this branch. Okay. Then I think it's a simple question. Find the probability that both of the marbles removed from the bag are of the same color. So I have XRR and YRR. Okay. So XRR is 1 over half into 7 over 10 into 7 over 10. Okay, I would also have blue. Yeah. XBB. Half into 3 over 10 into 2 over 10 plus half into 4 over 5 into 4 over 5. This is November 2352. I will have to open up the marking scheme. Um, yep, I think that's correct. That should give me, I don't have the final answer written here. Okay, 119 over 200. Okay. Then find the probability that bag Y is chosen given that the marble removed are not the same color. So not the same is 1 minus 119 over 200, what I just wrote above. Then Y is chosen. So what outcomes could I have? I could have this outcome, YRR, I could have Y. Okay, I could not the same color and bag Y was chosen. So YBR. So these outcomes. Half into 4 over 5 into 1 over 5 plus half into 1 over 5 into 5 over 5. I think that should work. Yep, that should give me 4 over 9 in total. I hope that's giving me 4 over 9 in total. Okay. Tim has 2 bags of marbles, A and B. So this is a similar question from November 5-3 now. Okay. Okay. Tim has 2 bags of marbles, A and B. Bag A contains 8 white, 4 red, and 3 yellow marbles. Bag B contains 6 white, 7 red, and 2 yellow marbles. Tim also has an ordinary fair 6-sided die. He rolls the die. If he obtains a 1 or a 2, he chooses 2 marbles at random from bag A without replacement. If he obtains a 3, 4, 5, and 6, he chooses 2 marbles at random from bag B without replacement. Find the probability that both marbles are white. Okay, there I could draw this with a tree diagram, but drawing 3 branches would be tough. But in fact, I would go ahead and do that. There are 2 different outcomes for the die, so that's what's happening first: 3, 4, 5, and 6. So that's 2 out of 6, and that's 4 out of 6. And then if this happens, what I do is I choose bag A, and that could be either white. Oh no, there are 3. Okay, so 3 would be tough. Let's not draw the tree diagram then. I thought there were just two. So with this, I have, if I want both marbles to be white, I want a score of 1 or 2. Okay, and then I want white and white, or I want bag B. Okay, let's call that A, in fact, or B white white. Okay, so A white white would be the probability of choosing bag A is 2 out of 6, and then white is 8 out of 15, and then 7 out of 14, plus 4 out of 6, 6 out of 15, and 5 out of 14. Okay, I hope those are the correct answers. Let me just open up the marking schemes alongside so that we know if we are doing this correctly. Yeah, okay, 2 out of 6, 8 out of 15. I think that's giving me 58 over 315. Find the probability. They've given you a lot of space, which means that they probably expect you to draw a tree diagram. Find the probability that the two marbles from bag B, given that the two marbles come from bag B, given that one is white and one is red. Okay, so given white and red, so I have a denominator that says probability of white and red, and I want probability of bag B, bag B. Okay, so let's first imagine probability of white and red. It would be probability of A, then white, then red, or it could be probability of A, red, and then white, plus probability of B, white, and then red, and probability of B, red, and then white. Okay, so I could have 2 out of 6. How many whites are there? Whites are 8 and red are 4. So 8 out of 15, 4 out of 14, plus 2 out of 6, 8 out of 15, sorry, 4 out of 15, and 8 out of 14. That's for bag A. For bag B, I have 4 out of 6. How many whites? Whites are 6, reds are 7. So 6 out of, I don't know how many it's a total. 13 and 2, 15. Okay, those are also 15. 7, 15, and 6. Okay, so those are the probabilities for just the denominator. Some of these will also appear in the numerator, which ones, the bottom two ones will appear in the denominator. So I'm going to be intelligent that way, and I will multiply. So that gives me 32 over 315, and 4 into 6 into 7 divided by 6 into 15 into 14, 2 out of 15. No, 4 out of 15. Okay, so 4 out of 15 plus 32 out of 315. That gives me 116 over 315 in the denominator, and then 4 out of 15 in the numerator. 21 over 29. Let's see if that is the correct answer. Yes, that is indeed the correct answer. Let's move on to the last difficult question that I have for you here, and that is this. Okay. This is also November 2353. Jai and Kaz and his wife Kaz are having a party. Jai has invited 5 friends, and each friend will bring his wife. So total of 10 friends. At the beginning of the party, the 12 people will stand in line for a photograph. How many different are there? Jai stands next to Kaz, and each friend stands. So there are 6 boxes. So 6 factorial. Each of these boxes has 2 factorial into 2 factorial into 2 factorial. into 2 factorial into 2 factorial. 1, 2, 3, 4, 5, 6. So 6 factorial into 2 power 6. 46080. I hope that's the correct answer. Yep, that is the correct answer. How many different arrangements are there if the 12 people, if Jai and Kaz occupy the two middle positions in the line with Jai's 5 friends on one side and the 5 wives on the other side? On the other side, okay. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So that's 5 factorial, and that's 5 factorial, and then Jai and Gaz could shuffle between themselves as well. Okay, and what could happen is that, let's say the men were on this side and then the women were on this side, then you could have a separate condition for women on this side and men on that side. That would also be 5 factorial into 2 factorial into 5 factorial. Okay, so what does that give me? 120 into 120 into 457,600. Okay, these two conditions are being added together. Okay, for a competition, uh, the party, the 12 people are divided into a random group of 5 people, a group of 4, and a group of 3. Group of 5, group of 4, group of 3. Okay. And find the probability that Jen and Kaz are in the same group as each other. So they could either be in the group of 5. So that means how many people are then remaining for. I want to find the probability. So if J and Kaz are here, that means that the best way out on this question. Three. Okay, so for probability, I'll first decide what my denominator is, and I'll say that if I was just to divide these people into these groups, I would say that it's 12C5 and then 7C4 into 3C3. Okay, that's going to serve as my denominator, and let's check what that would be. Okay, I will say that that is 12C5 into 7C4. 27720. Okay, now if Jay and Kaz were in this group, how many other people could be in this group? So I have 10 remaining, so I'm going to say 10C3 into 7C4 into 3C3. If Jay and Kaz were in this group, I would say 10C5 into 5C2 into 3C3 and 10C5, 5C4, 1C1. 4200, 2520, 1260. Let's see if that gives us the correct answer. When I put all of them together in the numerator, I put Jen Kaz into separate groups and 27720. 19/66. Okay, that brings us to the end of the difficult questions that I have for you. I hope this session was productive. I would encourage you to solve each of these questions yourself. You even if I'm not telling you the year, what you can do is you can sort of scroll from March 22, and they've been in order: March 22, then June 22, all of the variants and so on. Otherwise, you could just Google the question and still find them, or you could pause the video and solve the question as well. Up to you, but make sure that you solve all these questions. They are slightly challenging, and you will find them useful for your exam. Thank you for watching. I will be back with more videos in the next session. Thank you.